The purpose of this video tutorial is to show how to determine moment capacity based on mesh reinforcement input or distributed and unique reinforcement input from the DRD. This is applicable to both Builder 2010 and also Builder 2009 and can be done in Floor Pro or also MAT. So in this particular slab we have an elevated slab with equal geometry. It's symmetrical. The loading is 20 PSF dead load and 80 PSF live load. The slab is 10 inches thick. And we're going to go ahead now and select to input some mesh reinforcing, so we can use under the reinforcement toolbar we can select mesh reinforcement wizard after the slab has been selected. And here we have both top and bottom. We'll select bottom, keep the CGS values as they are, and we're going to change this to number 5s at 12 from number 3s at 12 and say create. So now we have, if I double click here, we have the same input shown. The mesh reinforcement extents are the extents of the slab. Now for the top rebar we're not going to use a mesh, we're just going to demonstrate how to input discrete reinforcing or what we call banded reinforcing. So we'll go ahead and select create banded. This is only available in the DRD module. You can select to create banded or distributed or mesh reinforcing. So for this we're just going to simply click two known points, and we can see the program will default to one number 3 bar. The number of bar is actually the bar that's used in the criteria for a two-way slab or a one-way slab. So that's a number 3 bar. So we can go ahead and change that. We can select that bar. We're going to change that to again a number 5 bar, and over the top we'll just say we have 4 number 5 bars, and this is cover from top or from bottom. Here we need to change this to top, and that toggles cover from top. So we'll just leave that as it is. And now we can go ahead and generate more banded reinforcing. Now if I want to change the parameters to begin with, I just click on the item properties box. I'll change this to top. We're going to have again 4 bars, and these are going to be number 5 bars. And now I can use that same bar quantity and size at each of my columns. So I'll just go ahead and say OK. Here this might be a shorter bar. I can do this in any direction I choose for this particular application of top rebar over columns. So we'll just do a few more. And again, these are saved as base reinforcing. They'll be used in the design or the capacity generation at each of the sections. The program does not specifically state that the mesh reinforcing or the discrete rebar satisfies some capacity or is greater than the demand moments caused by the applied load. So the program will always just add more reinforcing if the base reinforcing and the section does not generate enough capacity greater than M sub U. So we've input all the reinforcing we're going to input. Now we can go ahead and we can analyze this slab, and we can go ahead and design it to generate the moment capacities. Now what I've done is under criteria I've gone to analysis and design options, and I've turned on, or I need to turn on, the option to generate the design section moment capacity. So I'll turn that on. Notice here I also deselected the column strip middle strip option. That's set as no for this RC slab. If you select yes, more design strips and sections will be generated automatically. We'll go ahead and say OK. And then also what I need to do is under the loading tab, under load combinations, each of these is selected as a service or also a strength combination, meaning that the program is going to design those according to strength provisions or serviceability provisions. So I need to select to depress that or suppress that. I need to go ahead and select no code check for each of these options. This just will give us results. It will give us moments for each of these combinations, but the program will not design for any of them when you select no code check. And then the last one we'll select as no code check. Say OK, and now we'll go ahead and analyze the slab and design the system. So now the slab has been analyzed. We can go ahead and say yes, and I need to generate my design sections, so I'll go ahead and generate those. And if I use the support line results scaled toolbar, I can toggle then between the different support lines in their design sections. So one thing that's going to be important in reviewing the results is turning on the display or the number of the design section in order to compare results. So to do that, we'll go to select set view items. We're going to turn on the ID, and we may want to change the font height because of the density of the design sections in the slab. We'll just select 5. And now that was a little too small, so we'll go back to that and maybe we'll say 8. And now you can see each of the design sections has a unique ID number. So this is support line number 4 and design section 403004. So we can match these with the different results from the tabular reports that we're going to generate after we've designed the sections. So we'll go to FEM, design the design sections, and again nothing here is actually being designed because we suppressed the design check by selecting no code check. As an example, or to validate that, if I go to FEM and I say generate rebar for the envelope and I say OK, you can see that no rebar is required. So the program isn't designing any reinforcement. It simply generates the capacity based on the mesh and the discrete or the banded rebar that we've input. So to generate now the lists, we can go to Reports, Single Default Reports, Tabular, and under Design Section Data we're going to generate first we're going to generate the Design Section Forces Tabular Report. So we can select that for any load combination. We'll select it for example, let's just look at strength dead and live at the ultimate level. And now we have a Word document. It's a .rtf that opens up. And for each of the design strips, we have our section IDs and our moments, shears, axials, and torsions. So we're generally or primarily concerned about the moments here. So for each of the design sections, we can review moments along the length of each one. The second report that we need to print is we need to go to Reports, again tabular, design section data, and we want to report the design section moment capacities. So now we have the support lines with the design section numbers, and we have the positive and negative moment capacities for each support line. So now we can go ahead and we can match up these with this force design section data, and we can determine whether or not we have the proper capacity for each specific section. So this is how you would generate the moment capacities based on only mesh or based on input of banded or uniform, what we call base rebar in AdaptFloor Pro. And this will conclude the tutorial on how to generate moment capacities for mesh reinforcing and other base reinforcing in AdaptFloor Pro 2009 and 2010.